Module number 4, infinite series. Here first one we will discussing what is mean by sequence and series, then later we will discussing on infinite series. So first one is sequence. So sequence means it is an arrangement of any number or objects in a particular order is called sequence here. So you have to arranging either number or objects in the order wise. For example, 1, 3, 5, 7, etc. So we have arranged these numbers in order wise such that the common difference between 1 and 3 is 2, difference between 3 and 5 2, 5 and 7 is also 2. So difference between two number is 2 2 2. So it follows some rule here. So it is called sequence. Next example, 1 by 1, 1 by 2, 1 by 3 up to 1 by n. So you have arranged the number, fraction number in order wise, 1 by 1, 1 by 2, etc. Third example, 1 minus 1, 1 minus 1, 1 minus 1, etc. So here we will arrange the number in order wise such that we have arranged alternative signs of plus minus plus minus. So it follows the rule as plus minus plus and minus. So we will give one more example, 4 7 10 13 16 19 20. So it is called sequence here. So here the common difference between 4 7 or 7 10 or 10 13 is 3 3 3. So it follows the rule as difference as 3. So these types of example is called the sequence. So sequence means it is an arrangement of numbers or objects in the particular order. Then series. So series means we have adding all the numbers in the sequence, then it is called series here. Or we can say that it is the sum of all the numbers in the series. So if we add 4 plus 7 plus 10 plus 13 plus 16, then it gives the series here. So here we'll give the one more example. To make a series, form a sequence of first 5 positive integers 1 2 3 4 5, just add them up here. So here we will adding the numbers 1 2 3 4 5. So 1 plus 2 plus 3 plus 4 plus 5, it gives the 15 here. So it is called series. So series is adding all the numbers which is belongs to in series, then it is called series. Sorry, sequence, that is called the series. So in series, if the numbers are in countable number or infinite, or it contain infinite number, then the sequence is also called finite or infinite. If sequence is finite, series is finite. If sequence is infinite, then series is also infinite. Next one is infinite series. So infinite series means it is an expression in the form of u1 plus u2 plus u3 plus un up to infinity is called infinite series. So this series containing the infinite number or uncountable number of terms, then it is called infinite series, and it is commonly denoted as summation of un, or sometime we can denote it as summation n equal to 1 to infinity un. So un is called the nth term or general term of the infinite series, and the sum of first n terms of this series. So first n terms in series is denoted as Sn. So it is defined as Sn is equal to u1 plus u2 plus u3 up to un. So it is called the first n term of series, and it denoted as Sn. Then remark, the geometrical series 1 plus r square plus r cube up to infinity. So here we say that if r is less than 1, then it is called convergent. If r is greater than 1, then it is called divergent. So one more time we will repeat it. If mod of r is less than 1, convergent. If mod of r is greater than 1, that is called divergent. Second one, if the series 1 by n raised to p, where n value stands for 1 to infinity, 1, 2, 3, 4 up to infinite number, then series become 1 divided by 1 raised to p, 1 divided by 2 raised to p, 1 by 3 raised to p. So here if p is greater than 1, it is called convergent, and if p is less than or equal to 1, then it is called divergent. Convergent. So in a series, the sum of all the numbers are very close to the given number, then the number is close to the number when the numbers of the terms are goes on increasing and increasing. For example, the numbers converges towards the 1 here. So here we will given some number 0.9, 0.99, 0.999, etc. So 0.99 is very close to 1 compared to 0.9. 0.999 is very close to 1 compared to 0.99. 0.4 times 9 are very close to 1 compared to 0.999. Means when we increasing the numbers, then these numbers are very close to the given number here. So then it is called the convergent. Divergent. In a sequence, the number of terms or the numbers become constant and they continue. Means here the numbers are either increases or decreases continuously, and which is approaches to plus or minus infinity as the number n approaches. If number of n number increases plus or minus infinity. So in other words, here we can say that the limit does not exist plus or minus infinite values. So it is called divergent. By the help of convergent and divergent, now we will discussing Alembert's ratio test here. So statement, let the summation of un be a series of positive terms such that the limit un plus 1 divided by un when n tends to infinity is equal to lambda, then the series is said to be convergent if lambda is less than 1, and the series is said to be divergent for lambda is greater than 1. And here Alembert's ratio test will fail when lambda is equal to 1 here. Here we have given some standard limits. So limit 1 plus 1 divided by n raised to n. When n tends to infinity, the limiting value of this function become e. Similarly, the limit 1 plus x divided by n raised to n when n tends to infinity, its limiting function is e to the power x, and limit n raised to 1 by n as n tends to infinity, its value become 1. So you have to remember these standard limits e to the power x and 1. Now we will solving some examples on Alembert's ratio test here. First example, test for convergence the series 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube 4 factorial divided by 4 raised to 4 plus and so on up to infinity. So solution of the example. So we'll expressing the given series in summation symbol or summation of un form. So summation of un equal to 1 plus 2 factorial by 2 square 3 factorial by 3 cube up to infinity. Now we will writing the nth term of the given series. So that is un. So numerator is 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5, 6, 7 up to n times. So write this one as n factorial numerator, and denominator is 2 square, 3 cube, 4 raised to 4, 5 raised to 5, 6 raised to 6 up to n raised to n. So its nth term is n raised to n. So this series, its nth term become n factorial divided by n raised to n. So that is un. Then next one, un plus 1. So un plus 1 means in un we replacing n by n plus 1. So un become un plus 1. So in right hand side here also replace n by n plus 1. So numerator is n plus 1 factorial, denominator is n plus 1 raised to n plus 1. So now we will expressing un and un plus 1 as un plus 1 divided by un. So un plus 1 is this term, un is first term. So divide both the terms. So un plus 1 is n plus 1 factorial divided by n plus 1 raised to n plus 1 factorial. So denominator term n factorial divided by n raised to n. So it goes on reversing. So write this reverse form, n raised to n divided by n factorial, because it is in the form of 1 divided by n factorial by n raised to n. Now we know that n factorial means n plus 1, n plus 2, n plus 3, n plus 4 and so on. So similarly write the n plus 1 factorial as n into n plus 1 factorial, and in denominator we will splitting the power of n plus 1 as one is n plus 1 raised to n, second one is n plus 1 raised to 1 into n raised to n divided by n factorial. And in again denominator, so in n plus 1 raised to n, so you are taking n as common term here. So if you take n term outside the bracket, so your power is n, so n raised to n, and inside the bracket the term become 1 plus 1 by n raised to n. So it means that here we are taking n term as common. So keep it second term as it is, n plus 1 into n raised to n and n factorial. Now here we will eliminating n and n raised to n raised to n plus 1 and n plus 1 term here. So after cancelling these terms, so remaining terms are 1 divided by 1 plus n raised to n here. So which is the un plus 1 divided by un. So now we will taking the limit on both sides with n tends to infinity. So take the limit here. So left hand side limit as n tends to infinity un plus 1 by un. So similarly right hand side limit as n tends to infinity. And we know that the standard limit of 1 plus 1 by n raised to n, as n tends to infinity. So already given the standard limit 1 plus 1 by n raised to n is e. So here 1 divided by 1 plus 1 by n raised to n become 1 divided by e, and approximate value of e become 2.718. So 1 divided by 2.718, which is less than 1 here. So the given value is less than 1 means according to Alembert's ratio test, our summation of un become convergent, because in statement will given if lambda value is less than 1, so this series become convergent. So given problem is also convergent. Next example, second example, test the convergence of the series summation 4, 7, 10 up to 3n plus 1 divided by 1, 2, 3, 4 up to n into x raised to n, where x value is greater than 0. So here we will testing whether the given series is convergent or divergent. So already in example they will given the series in n format. So we will taking the given series as un. So un equal to 3n plus 1 n up to x raised to n. So that become un. Next we will require is un plus 1. So in un we will replacing n by n plus 1. So which gives un plus 1. So un plus 1 4, 7, 10. So in 3n plus 1 we will replacing n by n plus 1. So which gives 3n plus 4. Similarly in denominator n is replaced by n plus 1. So function become n plus 1, and also x power become x raised to n plus 1. Now we will dividing un plus 1 and un. So un plus 1 is this term, divide by un. So divide by un means this term become reversal. So interchange numerator and denominator terms. So which become 1, 2, 3 n, and denominator is 4, 7, 10 3n plus 1, and x raised to n become 1 by x raised to n. So here 4, 7, 10 3n plus 1 and 4, 7, 10 3n plus 1. So these two terms cancelled out. Similarly 1, 2, 3 up to n and 1, 2, 3 up to n. So these two terms also cancelled out. So here remaining term is n plus 1, and in numerator 3n plus 1. Now split the power of x raised to n and x raised to 1. So x raised to n cancel out. Remaining term is x here. So after cancelling the terms, remaining terms are 3n plus 4 divided by n plus 1 into x here. So now we are taking the limit on both sides with n tends to infinity. So in right hand side take the n term as common. So n into bracket 3 plus 4 divided by n. Similarly in denominator, after taking n as common, so which become 1 plus 1 by n into x. So here also n and n cancelled out, and if n tends to infinity, or if n value is infinity, we know that 1 by infinity value is 0. So 4 by infinity, 1 by infinity, its value becomes 0. So 3 by 1 into x. So our limiting value become 3x. Then again applying Alembert's ratio test. So this 3x is either convergent or divergent. So here 3x is convergent if it is less than 1, or x is less than 1 by 3, and 3x is divergent if 3x is greater than 1 or x value is greater than 1 by 3. and the ratio test will fail if 3x is equal to 1 or x is equal to 1 by 3. Third example, test for convergence the series 1 by 1 factorial, 2 square by 2 factorial, 3 square by 3 factorial up to infinity. So solution, first one, express the given series as summation of un, then we will writing the nth term of the series. So its nth term is un is equal to, so 1, 2 square, 3 square, 4 square means its numerator become n square and denominator is 1 factorial, 2 factorial, 3, 4 factorial, 5 factorial means n factorial. So the nth term of given series is n square by n factorial. Now find out un plus 1. Replace n by n plus 1. So which use un plus 1. And then divide un plus 1 and un. So un plus 1 un. First term is un plus 1 and second term become reversed here. So n square by n factorial become n factorial by n square. So now we will taking n as common in numerator. So its power is 2 means we will taking n square as common, and the term inside the brackets are 1 plus 1 divided by n. Actually it is not n square, it become n. Then in denominator again n plus 1 factorial means n plus 1 factorial, then n factorial and n square. So cancel it, n square, n factorial and n factorial. So remaining terms are 1 plus 1 divided by n whole square divided by n plus 1 factorial. So suppose if you take n as common in denominator, so it become n into bracket 1 plus 1 divided by n. So we shall expressing this term as 1 plus 1 by n whole square n plus 1 factorial, and again express denominator term as, so after taking n as common, so denominator become n into bracket 1 plus 1 by n. So 1 plus 1 by n square, 1 plus 1 by n. So one of the term will cancel it in numerator and denominator. So remaining terms are 1 plus 1 by n divided by n. So now take the limit on both sides with n tends to infinity. So 1 by infinity 0 and 1 divided by infinity. So 1 by infinity, our denominator is infinity. So 1 plus 0 divided by infinity, or it become 1 divided by infinity. And we all know that 1 by infinity value become 0 and 0 value is less than 1. And according to Alembert's ratio test, the given series is convergent. Fourth example, discuss the convergence of the series 1 plus 1 into 3 divided by 1 into 5. Second one is 1 into 3 into 5, 1 into 5 into 9, 1, 3, 5, 7, 1, 5, 9, 13 up to infinity. Solution, so express the given series as summation of un, then write the nth term of the series, that is un. So if you observe the terms, so first term is 1, second one is 1, 3, third one is 1, 3, 5, 1, 3, 5, 7. Next term is 1, 3, 5, 7 and 9. So here the number of terms goes on increasing and increasing in numerator as well as in denominator. So therefore its nth term become 1, 3, 5, 7, 2n minus 1, and denominator is 1, 5, 9, 13 and so on 4n minus 3. So if you substitute n equal to 1, we'll get it first value as 1. If n equal to 2, it becomes 3. If n equal to 3, it gives 5. So similarly in denominator n equal to 1, 1, n equal to 2, 5, n equal to 3, 9. So which is the nth term of un. So now replace n by n plus 1, which gives un plus 1. Then divide un plus 1 and un. So un term, first term is un, second term is reversed here. So here 1 3 5 7, 2n minus 1, 1 3 5 7, 2n minus 1 cancelled out. And similarly in denominator 1 5 9 13, 4n up to 4n minus 3, and 1 5 9 13, 4n minus 3 cancelled out. So after cancelling all these terms, so remaining terms are 2n plus 1 and 4n plus 1, and take n as common. So 2 plus 1 by n, 4 plus 1 by n. Again cancel it n and n, and take limit as n tends to infinity. So 1 by infinity become 0. So remaining values are 2 by 4 or 1 by 2. And 1 by 2 is less than 1, or 0.5 is less than 1. So by the Alembert's ratio test, given series is convergent. So these are the few examples on the Alembert's ratio test here. So for given series, you have to write nth term, that is un and un plus 1, and then divide un plus 1 by un, and take the limit as n tends to infinity, and check the limiting value, either it is less than 1 or greater than 1 or equal to 1, and according to that decide whether it is convergent, divergent, or the test will be fails if lambda equal to 1 or limiting value is 1.